our group will be presenting the importance of surface finish measurements in engineering industries. So the topics that will be covered in this presentation are what is surface finish, its characteristics, the importance of surface finish, surface roughness, its unit, how is it measured and symbolized, the types of surface finishes and how to choose the best. So what is surface finish? It basically is the nature, the overall texture of the surface that is characterized by the lay, surface roughness and waviness of the surface. It can be defined as the vertical deviations of a measured surface from its ideal form. So if these deviations are substantial, then the surface is rough, and if they are minor, then the surface is called smooth. Surface finish is also referred as surface texture or surface topology. Some basic characteristics of surface finish. Surface roughness. It is a measure of the finely spaced surface irregularities. Lay is the direction of the predominant surface pattern and is usually determined by the production method used to process the surface. Waviness, it is the longer space irregularities that deviate from the mean surface in the form of waves. These are caused by machine vibration and material warping, among other factors. Flaw, these are the unique surface imperfections such as holes, scratches, cracks, ridges that do not follow a regular pattern. Importance of surface finish. Surface finish is not only important to make the finished product look good and appealing, but from an engineering point of view, for many applications, the finish on a surface can have a big effect on the performance and durability of parts. The rough surfaces generally wear more rapidly and have a greater friction coefficient than smooth surfaces, and the irregularities tend to form nucleation sites for breaks or corrosion. However, roughness may encourage the desired adhesion. Hence, the required surface finishes are very much determined by the function and use of the component. A proper surface finish ensures that the final product looks better and lasts longer, which is not only beneficiary to the end user, but at the same time, some surface finishing techniques also help the manufacturers in the production process. For example, brushing the surface before applying paint can increase the metal's adhesion, and this makes a good quality finish easier to operate. And among the many benefits of paint, some of them are increased corrosion resistance, helping with the adhesion of paint and other coatings, elimination of surface defects, increased resistance to chemicals, improved conductivity and added surface conduction, increased strength and resistance to wear while friction effects are minimized, enhanced aesthetics and safety as the rough edges and burrs left can be a serious health risk too. So it is important to remove those risks by finishing the surface properly.
Okay.
Surface roughness. The terms surface finish and surface roughness are often confused. Surface roughness is the measure of macro and micro irregularities present on a finished surface. The surface roughness is a quantitative approach to find out the height of peaks and the depth of valleys of surface irregularities, and it is also a measurable quantity, and there are various instruments to facilitate such measurement. On the other hand, surface finish is a qualitative approach to designate the surface either by observing the surface or from the roughness value. And the attributes used for surface finish is very subjective and depends on application or the intended result. Also, surface roughness is often overlooked in the manufacturing process. More focus is generally given to the composition of a part and its strength or to its measured dimensions and tolerances. But a surface that is too rough can result in increased friction and premature failure of a part. So it is important to measure the surface roughness value, and also because surfaces in engineering applications must be within the desired limits of roughness for quality purposes. The ability to precisely measure roughness is crucial as it has an effect on the structural integrity, wear behavior, and surface and subsurface stresses.
Covering the topic of how to measure, how is the roughness and the finish measured. So there are usually a lot of parameters that are kept in mind and observed and analyzed while measuring the surface roughness of a sample. Uh, the many like the different parameters that are calculated are RA value, RY value, RZ value, and RMS values, and all of these are somewhat similar to each other in the sense that the peaks and valleys and the area covered by the peaks and valleys about the mean line is considered in a different way in each of these parameters. The most common one that is usually used in practice is the RA value. The RA value is also RA stands for the roughness average, and it's also known as CLA value, which is center line average. Uh, that value is used to determine the compliance of equipment with various industry standards. Uh, um, the smaller the value of RA is, the smoother the surface will be, and the standardizing bodies have come up with a grading number against each of the RA values, as you can see in the picture given. So for unified understanding of how the values will change and how the values are given to each of the surfaces, these ISO grade numbers are used. The the RA value is it's very common, but it's not sufficient enough to completely characterize the roughness of a surface. So depending on the application, the surfaces with same RA can perform quite differently. The value of RA can be found by measuring devices and measuring practices. The most common one is the manually done surface roughness comparator. Uh, and it's a simple method of estimating surface finishes, and it is used to uh, this handheld gauge is containing small samples of range of finishes, as you can see in this picture. So it is kept on the sample that we are inspecting, and by just by observing or by using a touch, we can come up with the grade or the roughness, the closest roughness value of the sample as compared to the comparator. It's a faster and easier method, and obviously cheaper, but it's not as accurate as the surface profile scanner or profilometer, which is one of the latest technologies in this field. It's this is one of the primary instrument used to measure the surface finish. uh, it is a contact method of finish measurement that employs a stylus that is automatically driven across the sample surface. The stylus observes and records the peaks and valley of the surface, typically perpendicular to the lay of the profile or the surface. So these two methods are widely used to find out the RA value of the surface given. Next comes the different way of symbolizing the surface and its finish, and how to improve its finish. So this is one of the simplest symbolization of the surface, and this there are of basically three types. The simple one on the leftmost one, that shows that the surface may be produced by any method, that the finishing of the surface can be done by any method, be it adding some material or removing the material from the topmost surface. The second one has a different symbol with an extra horizontal line here. This is used to symbolize that the surface should be finished by using material removal method. And the last one with a circle in between, it means that the material removal method cannot be used to improve the finish of the surface. We have to employ any other method to get the desired finish. Along with that, a number of values are used around this symbol to exactly show what values are used to what is the roughness of the surface and what values are used in the machining process. So if I look at the example here, the two values above the uh, leftmost line shows the maximum and the minimum roughness average values, the RA values. The the values on the upper side of the horizontal line give us the waviness height and the waviness spacing numbers. The value under the line give us the roughness sampling length. So length of the sample that is in observation. The symbol under this horizontal line tells us the direction of lay. As explained in the previous slide, lays are uh, uh, directional lines on the surface. So the direction is symbolized here under this horizontal line. So in a given drawing, there can be different symbols used on different surfaces of a given part only. It's not as if the whole part is the different surfaces of a single part is has to be finished using the same method. Different surfaces of a same part can be finished using different methods. So each surface is marked with a distinct symbol, and we can refer to that symbol and go about finishing the surface. So the further Aditya will be explaining different types of surface finishes.
Good afternoon, sir. I will be talking about types of surface finishes. The first process is adding and altering. It consists of electroplating, pickling, and powder coating. So electroplating is a process that involves the use of electricity. As shown in the figure, two poles, cathode and anode, are submerged in the fluid called the bath. The bath is a solution containing ions of material being added and the material being treated. The latter one is called a substrate. When applying the electric current, the substrate works as a cathode. So the ions are attracted to the cathode in the bath, which are deposited on the treated surface. So advantages of this process are durability, improved corrosion resistance, and reduction in surface friction. This is an example of electroplating. Next. The next process is pickling. This is an altering metal finishing process. The main use of pickling is to eliminate impurities and irregularities on the surface of the metal component. This method uses a substance called the pickle liquor, which usually contains some type of acid. Pickling is almost always part of the metal manufacturing process. Hot working usually leaves an oxide layer called the scale. Pickling helps to clean the surface by descaling it. This is in the picture you can see the metal before pickling and after pickling. Pickling improves the properties of metal such as corrosion resistance. The third method is powder coating. It is another adding process which involves the use of electricity. Instead of applying current through a liquid as in electroplating, static is used to deposit a dry powder. So after the powder is deposited electrostatically, the metal part is taken into a special oven to promote better adhesion of the powder through a chemical reaction. Powder coating is commonly used in automotive industry, tool manufacturing, and military applications. You can so this is in this photo you can see the procedure. Other types of method will be explained by Om.
Hello, yeah, am I audible?
Yes, yes.
Yes, yes.
Uh,
Very.
so removing. So the next thing is removing and reshaping. It is mainly used to alter the surface of the workpiece and attain a desired finish by removing or reshaping it. So the first method used in it is grinding. Grinding is used to produce a smooth finish on a flat surface. It is used if it is used machining process in which a spinning wheel is covered in rough particles, or grinding wheel which cuts the chips and non-metallic substances on the surface of workpiece, making it smooth. The surface grinding is most common grinding operation. Uh, the next the next is electropolishing. Electropolishing is also known as electrochemical polishing. Oh, sorry. Uh, it is in electrochemical process that removes material from the metallic workpiece, reducing the surface roughness by leveling micro peaks and valleys, and thus improving the finish. It is often described as reverse electroplating. The workpiece is immersed in temperature controlled bath of electrolyte. This electrolyte is usually made of varying ratio. Extremely sorry for that. This electrolyte bath is made up of varying ratios of sulfuric acid and phosphoric acid, and then the material is placed in it, and an anode is placed in it, and it levels up. The next is lapping. This lapping. It is a machining process in which two surfaces are rubbed together with an abrasive between them. This abrasive can be silicon carbide, diamond, etc. By hand movements or using machine. Lapping is used to for removal of material to produce a smooth, flat, and unpolished surface. It is a process reversed for products that demand very tight tolerance of flatness and parallelism. There are two various types of lapping: free abrasive lapping and fixed abrasive lapping. In free abrasive lapping, the slurry is applied directly to the lapping plate, whereas in fixed abrasive lapping, the particle is bonded to the substrate with the abrasive lapping pads. Now, how to choose the best type will be explained by Deepam.
So we explained almost 6 types of surface finishing methods. So once you're in the industry and you have given the part and you want to decide which it's a machine part and there are surface irregularities, and you want to decide which kind of method you will use to get a good finish on the part. So for that, the process you choose to obtain the surface finish, you require um, that depends on different aspects, and these 3 aspects are the key aspects that you have to keep in mind while deciding which process to use. First comes the production speed. You have to first keep in mind when you have to deliver the part and when you have to give it to the next process. When you have to give the finished product to the next process for assembly or for sale. So you have to compare the processing types or times of all the options available. So some for a small part, for say a, a kind of a clamp or a small part that is used, you need not go for powder coating or electroplating and waste your time in that. Instead, you can just grind it using a grinding wheel and get the desired finish. So that way you have to keep in mind which process will help you faster and in a more efficient way. Next comes the hardness of material. This is an very important aspect to keep in mind. The harder the metal you have, the more intense or stronger abrasive you will need. So you you have to consider the hardness of the metal, and in by by considering that, you have to decide which process to use for finishing. So some processes uh, might not be as effective as the processes based on the hardness, because if the material is very hard, the removal processes are usually preferred instead of adding. So you also don't want to go too hard with softer materials, as this could result in damages on the part that may be difficult to repair. The last is cost and budget. So of course, there could be processes that may seem the best option for your specific application. Say you consider the production speed and the hardness of metal, and come up with a process which is actually very costly, and you can avoid that cost and uh, choose a slightly say a longer processing time process, uh, but that way you can uh, juggle between cost and production speed and come up with the best possible process. So yes, making the decision cost effective is also obviously the one of the key factors. So these are some of the references we used while coming up with this report. So we are finished here. Thank you.